Hello everyone, welcome back to Let's Unbound. We have made it to the final FRQ, FRQ number 6 from the AP Calculus AB 2025 exam. And this is also a non-calculated question, so make sure to have your pen and paper and ready to solve along with me. So this one is a mix of concept. Like first one is proving the dy by dx for the given equation. And second part have line tangent approximation. Third point is vertical tangent case. And fourth point is uh, finding dy by dt given many known values to us. So very basic and simple. You can score the best in this question. So let's get started. And one more thing. As always, if you have any questions or doubts, feel free to drop them in the comments. I will be happy to help you here. So let's get started with this. Okay, I'm going to break it down one by one first. Consider the curve G, y cube minus y square minus y plus 1/4 x square is 0. Show that dy by dx is negative x by 2 times 3y square minus 2y minus 1. So very simple thing, implicit differentiation. Y cube minus y square minus y plus 1/4 x square equals 0. Write that and start differentiating. How I'm going to differentiate y? We are differentiating with respect to x now. Okay. So d by for differentiating, for example, this is the general formula we learned, right? So d by dx of sine x is cos x. Correct? But this time, what if you have sine y? Something made up of y, if you have, you should be careful. Okay? So it's not like actual formula. So y cube means just do the normal formula 3y square. Correct? And then you should do this first, like a chain rule, dy by dx. Then minus 2y, dy by dx. Next term is minus y. So 1 and dy by dx. When you come to purely made up of x expression of x, just normal differentiation, 2x, and you don't want to put dy by dx. No chain rule will be applicable here. So direct thing, and dy by dx of right side is 0 again. Right? So now I'm going to take dy by dx common out of all this because that is what I need. Dy by dx, 3y square minus 2y minus 1. And 2x by 4 is x by 2. That will, I will shift it over that side and minus x by 2. That's it. We are into the final part. So finally, dy by dx is negative x over 2, 3y square minus 2y minus 1. This is what they are asking us to do. This will not do a subtraction. These are in product, so it will go to the denominator. That's simple part A. I hope this is helpful to you. I think you understand this, right? Now part B. There is a point P on the curve G near 2, negative 1 with x coordinate 1.6. Use the line tangent to the curve at 2, negative 1 to approximate the y coordinate of P. Okay. So first equation of tangent. The main thing of tangent approximation is having equation of tangent. Okay, what are the things you need? First, write down the formula. Then you know what all things you need. Y minus y1 slope times x minus x1. We are using the tangent line to the curve at this point. So this is your x1, y1. And how can you find m? Your m is nothing but dy by dx. This will give you all of the slopes. Whichever point you need the slope, this will give you 2, negative 1. So dy by dx, we already have this stuff, minus x by 2 times 3y square minus 2y minus 1. Just now we proved this in part A. Now you're going to plug in 2 and negative 1. 2 for x, negative 1 for y. So negative 2 by 2, and I'm going to plug in this and solve. 3 times negative 1 when you plug in, positive 1. 3 times 1 is 3. Minus 2 times minus 1 is plus 2. Then minus 1. And 2 to cancel, negative 1 by 3 plus 2, 5, 5 minus 1 is 4. That's it. This is our slope, negative 1 by 4. Now I'm going to frame the equation of line of tangent. Sorry. So just plug in y minus, your y1 is negative 1. Your formula also have a negative, cautious. So y plus 1 is, m is negative 1/4, x minus x1 is 2. Make y as a subject. Y equal to negative 4th x minus 2, negative 1. That's it. I got my line tangent at the desired point. Now nearer to the curve, there is a coordinate 1.6. With x coordinate 1.6, what is y? So just plug in x is 1.6 in this. So y would be negative 1/4, 1.6 minus 2 minus 1. And negative 1/4, 1.6 minus 2 is negative 0.4, right? Minus 1. So you got positive 0.4 by 4 minus 1, which is 0.1 minus 1, which is negative 0.9. That's it. So at this case, the required y coordinate is approximately we found it. So y is approximately negative 0.9. That's the tangent approximation. Very simple B part, right? Now, part C. For x being positive, x greater than 0, y greater than 0, there is a point S on the curve at which the line tangent to the curve at that point is vertical. Find the y coordinate of the point. So a line tangent to the curve is vertical means vertical tangent have undefined slope, right? So dy by dx is undefined. Undefined means something by 0 only, it's undefined. Correct? So all you need to do is take your dy by dx, which is minus x. Again, part A, what we proved, that stuff you have to take. And you need to set denominator to 0. This condition is giving the vertical tangent. So we're going to do 3y square minus 2y minus 1 equals 0. Why I'm not taking 2? 2 is 2, fix it. So this have to be 0. Let's see for what values this becomes 0. So do the quadratic factorization. Multiply the first and the last end. I hope you know the trick, but still, you got minus 3. And whatever the middle term coefficient, the linear coefficient is minus 2. 1 times 3 is 3, but I need negative 3. I'm going to give negative for 1. It works well for multiplication, the product, but not for the sum. Sum is I'm getting positive 2 in this case. I'm going to check the sign with minus 3. Yes, that makes sense. 1 times minus 3 is minus 3. 1 minus 3 is minus 2. These are my two numbers. Okay, let me tell you how to directly write the y values here. So y is, just take the inverse of the, if you got 1 in this, put minus 1 divided by the leading coefficient 3. That's it. Now, if you got negative 3, like just inverse the sign, I will put positive 3. Leading coefficient is 3, so which is 1. That's it. I got my y values. Y is negative 1/3 and y is 1. But negative 1/3 is not accepted because they clearly mention y is greater than 0. So y equal to 1 is the required y coordinate. Okay, this shortcut will help you if you are not aware about it or you want to go with the traditional way of solving this. Let's do it with that. So again, still this process is same. Okay, so 3y square minus 2y minus 1 is 0. Using these two numbers, you split the middle term. 3y square minus 1, 0 stays as it is. Now, instead minus 2y, I will put y minus 3y. Then factorizing, take common things out. You can take y common from the first two, 3y plus 1. From this, you can take negative 1 common, 3y plus 1. Now you take 3y plus 1 common. That will be y minus 1 equals 0. That's it. If the product of two things is 0, any one of them should be 0. So 3y plus 1 is 0. That will fetch you y is negative 1/3. Y minus 1 is 0 will fetch you y is 1. Again, you will dismiss this due to the restriction and we will take this. Okay, this is another way of solving. You can use whichever is easy to you. Now, part D, the last part of the last FRQ in this playlist. A particle moves along the curve h defined by the equation 2xy plus ln y equal 8. At the instant when the particle is at the point 4, 1, dx by dt is 3. Find dy by dt at the instant. Okay, given dx by dt, we need to find dy by dt. I'm going to differentiate this with respect to t. Okay, so d by dt of 2xy plus d by dt of ln y equal d by dt of 0. Now, here on important thing, x is not just x. X is a function of t. Y is a function of t. Okay, so x means f of t, like y is g of t, something like this. Okay, so don't say, don't put, okay, d by dt of x is 1. It's completely wrong, right? So now take 2 common out and x and y are two functions in product. So you treat it as UV. I hope you remember UV method is differentiation of product is U prime. First thing, you need to differentiate and then V prime U. Okay, my u is x. If I differentiate, it's not 1, it's dx by dt. Then second b as it is. Then I'm differentiating b, dy by dt, and x as it is this time. Now, d by dt of ln y, like 1 by y times dy by dt. So you differentiate, and this is a function of t. I need to differentiate that chain rule. D by dt of 0 is 0 again. Now, what are the things you know? You know x is 4, y is 1, dx by dt. So plug in. 2 times dx by dt is 3 times y is 1 plus dy by dt is what I'm looking for. Let it be as it is. X is 4 and plus 1 over y is also 1 dy by dt. Now I need to simplify and make dy by dt as a subject. So this is 3, right? 3 times 1 is 3. So take 2 inside. 6 plus 2 times 4 is 8 dy by dt. And here I have 1 dy by dt. Just dy by dt is enough, right? Equals 0. And 8 plus 1 is 9 dy by dt on your left side. And the 6 I'm taking it to the other, minus 6. Now dy by dt is nothing but negative 6 over 9. That's it. So dy by dt again divided by 3 to simplify this, negative 2 over 3. That's it. So at this instant, dy by dt is negative 2 over 3. This completes the solution for part D. So all this is about, it's the main essence of the question is to test your implicit differentiation skill, correct? So this is completely a different one, and the first one we proved that is a complete different one, right? That's the wrap for FRQ 6, and that is the last question. So thank you so much for watching with us, and we hope this entire playlist is helpful to you to learn, practice, and build the confidence, and the step-by-step explanation is helpful. If yes, you can like, share, and subscribe and to show your love. And if you want to share any suggestions or topics or feedbacks on the videos which have posted so far, you can always share it in the comment section. And yes, AP Calculus BC playlist for 2025 exam is coming very soon. So stay tuned for that. And you can subscribe and click on the notification bell so that once the video got posted, you will immediately get it, right? And if you have, we love hearing your feedback and ideas too. If you want to join Let's Unbound student community WhatsApp group, a link is given in the description. So click now to connect with the fellow learners. Like, share, subscribe, and hit the bell icons to stay updated with our future content. Again, thank you for learning with us. Keep learning, keep practicing, and we will be seeing you in the next playlist very soon.